Okay, in this lecture we want to find out how we can determine the operation region of the BJT. So for determining the operation region of the BJT, we basically have two different ways. One way is to find out the voltage between the base and the emitter and the voltage between the base and the collector to determine whether the BE and BC junctions are forward or reverse biased. And the other way is to find VCE, the voltage between the collector and the emitter, and the collector current. Then we can use the transistor graph, the BJT graph, in order to find the operating point of the BJT. So first, by an example, I will show you how we can find the operating region of the BJT without using the graph. So in this example, we have basically three known quantities, which are V1, V2, and V3. So we have V1, which is also equal to V base, is equal to 2.7 volts. We have V2, which is equal to V emitter, is equal to 2 volts. And we have V3, which is equal to V collector, is equal to 2.3 volts. So as I said, to determine the region of the transistor, we shall compute the VBE, which is the voltage between the base and the emitter, and VBC, which is the voltage between the base and the collector, to determine whether the BE and BC junctions are forward or reverse biased. So basically we have two definitions for the regions of the transistor. So first we have the saturation region, and then we have the active region. So basically in the saturation region, both junctions, so both BE and BC junctions are forward biased, and in the active region, the BE junction is forward biased, while the BC junction is reverse biased. Okay, so here we want to find VBE and VBC. So VBE is equal to VB minus VE, and in this example VE is 2.7, VE is 2, so the difference will be 0.7 volt. And then we have to find VBC, which is also equal to VB minus VC, and in this example we have 2.7 for VB and 2.3 for VC, and it will be 0.4 volt. So as we can see, both of these junctions have the voltage greater than 0, 0.7 and 0.4. So we can conclude that both junctions are forward biased. So we can say that both junctions are forward biased. So with regards to the definition of saturation region, we can say that this transistor, the operating region of this transistor, is in the saturation region. So this was the first method to find the operating region of the BJT. So in this method we do not need to use the graph of the transistor. So the second method for finding the operating point of the BJT is when we have the graph, and our graph is I collector, so IC, versus collector emitter voltage, which is VCE. And as you can see here, we have the waveforms, different waveforms for the operating regions, for the operating of the transistor for different base currents. So basically, in this method, we have to find the I collector and the voltage between the collector and the emitter. So in order to find the voltage between the collector and the emitter, for example, in that specific example, we have both VC and VE, so we can easily find it. And the other thing is that we have to find I collector, and for finding the I collector in this specific example, we can see that I collector is the voltage at this point minus the voltage at this point, so we're gonna have VCC minus VC over RC. So then we found IC, the I collector, so we can specify it on this axis, and then we have also VCE, so we can specify it on the other axis, and then the intersection of that 2 points will give us the Q point or the operating point for the BJT. Thanks.